An important part of the maintenance of a steam system is surveying the steam trap stations within the system. Surveying is the process of inspecting equipment to detect problems or malfunctions. Different problems may become evident as the various pipes, valves, traps, and strainers in a steam trap station are checked. Before you begin to survey a trap station, you should familiarize yourself with the normal operation of the steam system in which the station is installed. Make sure that the system's steam is pressurized and is reaching the trap station. You also need to know whether the system normally has a constant steam flow or a modulating or varying steam flow, because the type of flow affects steam pressure. It's important to check both the pressure and the temperature of the system's steam. First, note the steam pressure and temperature at the inlet for the equipment to which the system is supplying steam. Then compare these values with the recommended temperature and pressure for the equipment. Usually, if the pressure or temperature isn't within the recommended limits at the equipment inlet, the pressure or temperature at the trap in the trap station will also be incorrect. Whenever this occurs, the source of the problem should be traced, so corrective action can be taken. Another essential task in a trap station survey is checking pipes for damage and leaks. You should also make sure that the drip line is connected to the lowest point in the steam system. The drip line must be sloped toward the trap to avoid pockets that might cause sluggish condensate flow. The slope also ensures that gravity will keep condensate from building up in the line and causing water hammer. The drip line must also be large enough to carry the volume of condensate that's being produced. It should never be smaller than the trap inlet. Often, condensate from a trap discharges into a return line, which should be checked during a trap station survey. The condensate return line may be elevated, as it is in this installation, or it may be placed low so that condensate can drain from it by gravity. Either way, the condensate return line must be large enough to carry the total volume of both the condensate from the trap and any flash steam that's formed. Generally, a condensate return line should be at least as large as the trap outlet. The back pressure at the trap outlet should be checked to make sure that it's not too high. If there's no gauge downstream of the trap, you may need to install a temporary gauge so you can check the back pressure. For most thermodynamic traps, the downstream pressure should not exceed 70% of the upstream pressure, but the manufacturer's instruction should be checked for the allowable back pressure for a particular trap. Increased back pressure will cause the trap to cycle open and closed more frequently, and it also reduces trap capacity. Likewise, if several thermodynamic traps discharge to a common return line, it's essential to make sure that the condensate return line is large enough to handle simultaneous discharge without developing excessive back pressure. For other traps, like this inverted bucket trap, increased back pressure may reduce trap capacity, but it doesn't otherwise significantly affect trap performance. Another task that's usually part of a trap station survey is making sure that the trap strainer has been blown down. If this hasn't been done, opening the strainer blowdown valve one full turn and then closing it will usually provide enough flow to clean out the strainer. Finally, you should keep a record of the trap station's performance or operating history. Reviewing the operating history may reveal specific problems that should be checked during a survey of an individual trap, or it may clear up questions about how the trap station has performed under certain operating conditions.